Now, the most familiar way to visualize a function is probably through its graph. And the way we construct a graph is by first constructing a Cartesian coordinate system. We lay down an x-axis and a y-axis, and we're thinking of the x-axis as the set of all possible inputs, so the x-axis represents the domain of the function. And then what we do is we plot points in this plane, and each of the points that we plot has to satisfy the function. In other words, the x-coordinate of the point has to be some valid value of x, a valid input value, and the y-coordinate has to be the value of the function at this input value. So, for example, an input value of x equals 1 is in the domain of this function, and so we are going to plot this point on the plane because the x-coordinate of that point is 1, and the y-coordinate of that point is the value of the function at 1. In other words, the coordinates of that point are 1 and f evaluated at 1. Now, this curve in the plane here is the set of all points that satisfy the function. So as another example, the value x equals 2 is also in the domain of the function, and so this point here lies on the curve because its x-coordinate is 2, and its y-coordinate is the value of the function at 2. And as I said, this curve in the plane here is the curve of all points that satisfy the function. So in other words, for each point along that curve, the x-coordinate of the point is in the domain of the function, and the y-coordinate of the point is the value of the function at that input. Another nice thing about the graph of a function is it allows us a simple way to visualize both the domain and the range of the function. The domain of the function is the set of possible input values for the function, and so you can see the domain illustrated here. The range of the function is the set of all possible y values that are swept out by the function as x varies across the possible values in the domain.